lumped capacitance. In lumped capacitance, we're going to see how to make sense of very practical and very real life cases, things that are way beyond our intuition, but using what we already know, we can start making predictions about systems that might seem complex. I have uploaded the notes, and there might be some improvements, but the notes already have much of what we'd like to discuss. So in these minutes we have, what we're going to do is consider the case in which the energy balance determines the whole system. And this happens when the whole system is at the same temperature in all its volume. So if it is at a whole temperature in all its volume, the gradients are zero, so I don't need to worry about conduction, heat transfer inside this body. Now that's pretty cool. And this is a very common case. We will see under what circumstances we can apply this simplification, and it's under many, many cases. We're not going to see this now. We're going to see this on week 4 of classes. But right now, let's say when, let's assume we know when, I will tell you at this stage when, you can assume that the temperature is the same, that the surface temperature is the same as the temperature at the core, and anywhere on the surface, the temperature is the same, and anywhere in the volume, the temperature is the same. Then we can do very interesting calculations. In these calculations, the temperature of the body is a single number, T. Anywhere in there is T. And the mass times the specific heat times the temperature variations is going to give us the variations on the whole energy stored in this body. Now we can combine this energy stored that we know because the temperature is the same in the whole body with our knowledge of how heat is gained or lost through the surfaces by convection or radiation, right? How is lost through the surface? Could even be contact. So the methodology we will follow is similar to what we have seen so far. It is, we determine the control volume and we make an energy rate balance. You know how to do it. 2, we will assign expressions for heat in, heat out, heat generated, and heat stored. We know how to do it because we'll do we'll do convection, radiation, contact, whatever it is, heat generation. We are going to put these expressions into the heat energy balance. And here happens what you like the most, right? You end up with a differential equation, and you like it even better because we'll solve it. But the same things we have done so far, they build to the point in which we can write now an equation that is not obvious at all, that is a differential equation. And we're going to look at the cases in which this equation is simple enough that we can solve. It's our time now, and we'll pick up on this on Monday. Thank you very much. Have a great weekend.